morning, guys. How was your long weekend? Anyone went anywhere? Okay, I had some new experiences last weekend. I went to the volleyball game. That was my very first time watching the volleyball game. Yeah. Who went? Anyone? Only I was having fun. Okay. All right. So how about homework one? How's homework one? At least you have started. Okay, so don't forget it's due this Friday. And I think I forgot to emphasize it a few more times that I'm pretty picky about how you're going to submit it. So please submit it in like letter size paper. I don't care whether you have something printed in the back before. So have it on letter size and not on any kind of other papers. Or try not to use the loose leaves because it's different sizes. And then staple it on the top left corner. Okay, kind of specific, but I hope you can do that. How about the project? At least you have started. Okay, so don't forget that you will present it next Friday. So I've been getting some questions regarding to the project. So you will be giving a presentation. At first, I think on the website I say 5 minutes, but can we make it 4 minutes a team? Is that all right? Because I realize we have 13 teams, and that will exceed the time if we do like 5 minutes a team. The next instructor won't be happy if we stay here over time. So we will try to make it 4 minutes, if that's all right. Okay. Okay. So then. Yeah, I'm sorry about the urgency for the VPN thing. I was thinking I would feel bad if I send email on a vacation, but then that's like 1 day left for you to figure everything out. So if you don't have it figured out today, that's all right. We still have another lab on Friday. Okay, so today, if you have already figured it out, that's awesome. If you don't want to figure it out, yeah?
Can we run SQL locally?
Yeah, just about to say. So if you don't want to figure it out and you actually install it on your local machine, that's totally fine for me. Okay? So at first our intention was that it might be easier if we help you to skip the steps to install things, but it turned out maybe the VPN is more annoying. So you decide, okay, whether you want to use the VPN and then use the account we set up for you, or if you want to install on your own machine. Okay? I think in my experience, installing on Windows is a lot more complicated than installing on Mac or Linux. So if you're using Windows, what I would suggest is you can just have a virtual machine and then that will make it so much easier. Last thing before we get started, I want to ask you guys about homework 2. So at first I have homework 2 due October 2nd, and I plan to include both chapter 3 and 4 into this homework. However, the midterm is September 29th. So I'm wondering whether you guys want to move the homework a bit earlier so that you can know the answer. Maybe we won't be able to grade it before the midterm, but you will have the answer key for that homework and then you can use that to review midterm. Would that be a better plan? So what I'm planning to do, maybe I'll move this homework to the Friday of week 5. So after this Friday, after you submit homework 1, I will have homework 2 posted, and then you have another 2 weeks to work on that. And because, even though I say we will include chapter 3 and 4, but because chapter 4 will finish on the day you submit the homework, so for the very last part of chapter 4, I won't include that to homework 2. Sounds good? Okay, so I'll change that when I go back to this. But yeah, just remember, midterm 1 will be the end of September. So that's that. Let's move on to today's lecture. I think I didn't put too much for you guys to write today because I feel like we should focus more on typing. Okay, lecture 7. So, just a little bit of really basic commands that we might be using today. I think I didn't stretch it enough last time. So later on today, whenever you want to, I think that's the first step. later when we get into MySQL, you want to show what are the databases you have, you just type show databases. And last time I also didn't emphasize it, but don't forget you need semicolon after every command before you hit enter. Another thing is, okay, so after you show the databases, you will get a list of databases that are you can view. Then you can choose the database that you want to use. So later on, I'll show you. You can say use whichever database. Then in database we have tables, which are the relations, right? So then you can show the tables. I will assume you have not created anything in your account or your local machine. So when you show the tables, what you get? You should get an empty set, right? Because we have not yet created anything. And these two, I think I talked about last time. So if you want to see the schema of a table you created, then you can describe the table. Okay, later on I'll show you. And also, if you want to just show the contents of a table, which is all of the rows in a table, you put select all from the table name. Okay, so these are a couple of commands that we'll repeat using. Okay, before we get to MySQL programming, let me just go through a couple of concepts that we didn't finish last time. So let's talk about key constraints first. Last time we focused on creating tables and I think inserting values and modifying, right? For modification, we try to do add column. Then today we will focus on key constraints, right? So a set of fields is a what for a relation if no two distinct tuples have same values in all key fields, and also no subset of the set of fields, and a key is a unique identifier for a tuple. If you remember, we have primary key for the key. What is the other one? Yeah, candidate key. Okay. So when I was reading the two definitions, I actually found it really confusing. So the first one was fine. It said no two distinct tuples can have same values in all key fields. But then the second one said no subset of the set of fields in a key is a unique identifier for a tuple. Just keep in mind, when we say key, it means candidate key. So people call candidate key a key as well. So the second definition, no subset of the set of fields in a key is a unique identifier for a tuple. If we think about this, let's say in this example, SID, normally if it's an ID, we say it's a unique identifier, right, for all of the records. So can this one be a candidate key?
No.
Why is that?
Because IDs.
Because, yes or no? Yes or no? Someone says because SID is a unique identifier, right? So if we think about it this way, SID is a unique identifier, and SID is a subset of this set. So this set, according to this rule, right, this rule, it cannot be a candidate key. Does it make sense? So I was thinking, in general, if we could only consider a set that has only SID, is a set containing SID a subset of a set containing SID? So I think normally we would say A, when you do that, right? Then A is a subset of B. Okay, so for here, if we do that, that's strictly a subset. Okay, so when I was thinking about it, at first I thought about this, which includes the equal condition. But for here, we don't consider the equal part, so it's strictly a subset. So that's why for SID, if a set only has SID, we don't say it is a subset of another set that has SID. Okay, so that's just, here they didn't make it really clear, but I think if you want to follow the definition, you have to think about subset in a way that's strictly a subset, excluding the equal situation. So that's for key constraint. So, if we don't call this a candidate key, so the answer is no, right? This is not a candidate key because of this rule. So if we cannot call it a candidate key, it also has a name. It's called a super key, okay? So for super key, it is a set of fields that contains the key. And because of that, so we can say a tuple or a record in a table is always a super key, right? Because they always contain key. So only one candidate key, okay, done with super key. Only one candidate key is chosen to be the primary key, if you remember, right? So if we have so many candidate keys in the table when we define a schema, do you think we can just pick whichever? Or there are some situations we have to consider to make it better? What do you think? If we have so many candidate keys, does picking whichever are all the same? No, right? So sometimes there are different reasons why you pick certain keys. So one of the biggest reasons is for some of the keys, DBMS may create an index with the primary key fields as the search key. So some keys is just easier for the whole indexing process. Okay, other time it's just these keys are more intuitive. That makes more sense to use. All right. So now we want to go to some programming. Before we get started, I'll just show you how it will look like if we want to specify some key constraints. So last time we created very simple students table, right? I think we only got until here. Okay, we just specified the SID name, login age, and GPA, and their domain constraints. So this time, if you use unique, that's for candidate key. Okay, I think I don't have that on the slide. So unique is for the candidate key, and primary key is for the primary key. Okay, so you just use these two keywords to specify that. Okay. Let me see. Okay, let's move to. Are you guys connected to the CSC VPN, or is it working on your local machine now? Who needs more time to set it up? Okay. So I try to make the font super big. Is it big enough for you guys? I was trying to set the background not so kind of transparent, but I think it looks fine. Okay. So I'll assume you already have your terminal open, or you already SSH, like by PuTTY, whatever. So now, okay, I'll do SSH. You can pick whichever machine, okay? So if you have read through the instruction, you can just put P218 and INST, and for the 30, you can pick all the way from 09 to 33, right? Just to make sure we're all on the same page, if you don't know what I'm talking about, this is written on the Oh, I'm not connected. Give me 1 second. So who uses this smartphone to connect it? Okay, it's kind of bizarre, right? I don't know why. Just give me 1 second. Anyone connected? Okay. Did it take longer? That's my problem. No, I can't even type in it. Wait a second. not sure what's going on. Give me one more second. John, were you connected to the PSU?
Yes.
And then you just open internet.
Is your internet working? My internet wasn't working a second ago.
Yeah, it said the domain resolution was unclear or whatever. You guys can discuss some of the materials or whatever. Give me 1 second. I don't know what's going on. Okay, if yours wasn't working, try the AP Wi-Fi. Okay, so we're now in CSC network. Okay, so if you are also using the Linux terminal, what you want to type in, instead of using PuTTY, you will use SSH and your CSC account at whichever machine you want to use. Okay, and so as I said before, if you are not sure what I'm talking about, I list that under the lab page. So that will be here. Okay. So for the machine that you can choose all the way from 09 to 33. Okay? Everyone with me? So once you have that, you hit enter, and you type in your CSE password right here, not the one Barbara sent you. Okay? So then we're in. Okay? So once you see right here, it means you're in one of the Linux machines in the Linux computer room. Alright, so now we want to get into your MySQL, and to do that, I list the, here. That's the command you will need to do. Okay? So do that. And here's where you type in the password Barbara sent you. Okay? And then we are in MySQL. Okay? Alright, so now we're in MySQL. Anyone wants more time, or I can keep going? Yeah.
Am I allowed to just use the MySQL Workbench GUI?
What?
Can I use the MySQL Workbench GUI, or do I have to do it from a terminal window?
If you have it, then you don't have to do it from here.
Okay.
Yeah, I just want to make sure that you know the commands and stuff.
Okay.
Yeah, yeah.
The command she sent to change your password, that didn't work.
Oh, really? I just never changed this. Somehow memorized it. Yeah, but okay, I'll ask her to see whether maybe she sent the wrong command, I suppose.
I mean, maybe I typed it wrong.
Yeah, okay, I'll ask her. All right, so now we're in MySQL. So what should we do? We want to see what are the databases available. You can do show databases, right? So if you hit enter, you'll see these two. Okay? don't want the information schema for now. But for the second one with your account, that should be the one Barbara built for you. Okay. So before we type in any commands, creating any tables, we want to make sure that we use the correct database. So how do we do that? We want to do use, and then just type in the database name, the database you want to use. Okay? And you hit enter, and it will just tell you database changed. Okay? So as I said earlier, now I always assume you just start. Let me see what I mean. I'll just assume that you start from no tables created, okay? So we want to see what are the tables in there. You just put show tables. Then that will tell you it's an empty set because we have not yet created anything, okay? So let's start from creating the students table. Remember from last time, we want to create tables. What should we do first? What are the keywords to start? Create tables. Okay, we do create table. Okay, you put the table name that you want to create. So when you're in this MySQL shell, when you hit enter without putting a semicolon in the front, it will just assume that you're continuing entering the command. So you can split the line however you want. So let's specify the schema, as we are pretty familiar with. I also have it on the slide, so you can just copy the exact same thing. We want it to be integer. Then these two are sort of different from last time because today we actually specify what is the candidate key and what is the primary key. Okay. If you're done with that, hit enter. So if you don't have any error in the command, it will tell you query OK. And because we are just creating a schema and like an empty table, so it will actually tell you 0 rows affected. Okay. So if in the middle of it you type something wrong, just type semicolon and enter. Yeah?
I think it was GPA.
Yeah. Thank you. Yeah, I missed GPA. So there are ways that we can add columns, right? But should we do add columns or do it again? Still torn. Okay. I want to keep it the same. I think I can. No, I'll just drop the table. Remember, drop table is like delete the whole table, right? Okay, I'll do it really quick again. Sorry for those who were following me and typing the wrong thing. GPA. So again, unique is for candidate key, and primary key is for primary key. Okay. Everyone has the, yeah?
I know like the first week you had mentioned that instead of storing age, it'd be better to store date.
Yeah.
Is there any reason that we're like not doing that?
You mean, storing date of birth? I'm just following the exact example as a textbook.
Okay.
So the textbook's reason is for just for education purpose, so we are not storing the age.
Yeah.
But when you're designing, storing age is bad. Yeah, that's a good point. So we're using age now, but when you're designing your online shop, try not to do that. Okay, so now we created the table and we want to review a bit about the schema we did. So if you want to see that, you can do describe the table, okay? And that will show you this. It's kind of ruined now because I made the font too big, but you can see here it will tell you what are the fields, right? And what are the type for the fields, and whether they can be null or not. And as you can see, the SID cannot be null, right? And the reason is because SID is primary key, so it cannot be null, right? And it will tell you SID is the primary key, okay, stuff like that. So now we created a table. What do we want to do next? We should insert some information in it, right? Now it's just empty. So if you want to see what are the contents in the table, you can do select all from the table name, right? So what you will expect is empty set, correct? Okay. So the example that we will follow today, we will create two tables, okay? And the example we'll follow today will be on your slide 7. I have some of the same example from the textbook. So since I think typing in inserting value is boring, I have it Angel. So if you don't want to type that in, type the exact information as the table shown on the slide. You can go to the lab folder, and I have like a script right here, just 2 sets of commands. So for the first set right here, if you copy that, then that will insert all of the values that we will go through for the student's table. Okay, I think that will just make it easier. You do that, it looks really easy. If you just paste it, okay, copy and paste it, then it will tell you 3 okay, and now this time because we insert 6 instances, so 6 rows are affected, and it will tell you we have 6 records in total, and there are no duplicates. So remember, even though when we introduce the relational model, we say duplicates are not allowed, but in commercial purposes, sometimes they're allowed. So in MySQL is the same. Okay. So this time, if say we want to see what are in the student's table, do the same. Select all from students. When you hit enter, then you will see the contents. All right. Now let's get back to the slides real quick. Right here. Okay, so now we have the student's table, and we want to create a relationship of it with the course. We won't get into the course table today, but we will do the relationship table, the enroll. Okay, so remember we are saying before, if you want to identify any specific relationship in the relationship table, you will need to use information from here and there to identify it, right? So what we will need, for example, right here we created a student table and enroll table. Here are the schemas of them. So what you will need is, like for the enroll table, we have an STUD ID, the student ID, referring to the SID in the student's table, right? So for that, we say the STUD ID in enroll is the foreign key. Okay, we will call it the foreign key. That refers to students. Okay. So that's why we have that pointed from STUD ID pointing to SID. So let's take a look at the example that we will be using throughout the practice. this will be the enrolled table, and that would be the students table. Okay? So here I say only students listed in the students relation should be allowed to enroll for the course, which makes more sense, right? If today you have a tuple here having a student ID that actually does not exist in the student table, that should not be allowed, right? So if you look at here I have the arrows, all of them can map to a student in the student table. So in order to do the foreign key in SQL command, this is what we will be doing. Right? We will create a table calling row, same thing that we repeat here. Okay? We have just the student ID, course ID, and grade. And this one, I think last time a student mentioned that after class. So we were saying we don't have specific primary key for the relationship itself. It actually both come from the two tables that it's related to. So this is how you look at it. The STUDID is from the students table, and the CID will be from the course table on the other side, right? And here is how we do the foreign key. So you say foreign key, as we said earlier, STUDID is the foreign key, right? It references to students SID. Okay, so this is actually not complete because you actually also have to say CID references to the course CID. But we are not creating the course table today, so let's just forget about that for now. So this will be how we normally do it, but if you are using the CSE MySQL account, actually there's a little problem that I found yesterday. So exit this real quick. So after you finish right here, you will actually also need to put an engine that you want to specify. I didn't know this before, but I found out yesterday that by default the CSE machine is not using this engine. So the engine that it was using actually will not support relational table, which is kind of crazy. So the engine was using cannot allow you to do any foreign key. So just remember, I think for those, if you install locally, maybe by default it's already this engine, so you don't have to worry about it. Okay? But if you're using the CSE one, just make sure you also specify, I want to use this engine. And another thing that I didn't do earlier is because we have foreign key in the enroll table referencing to the students, so it would expect you to reference to a table that's also created with this engine. And I forgot to do that, so we have to do it again. But just remember when you go back to the students table, you also specify the engine. Otherwise, it will give you an error saying you cannot reference to that. So let's get back to here. And I think this might be a bit annoying, but we're going to drop the table again because I forgot to put the engine. So don't hate me. Okay. Oh yeah, just a reminder. So if you use drop table, that actually deletes the whole table, including the schema. But if you use truncate, what does that do? Anyone remember? Yeah, only delete the rows, but the schema still exists. Okay. So I'll drop it again, so we can make it connected to the enroll table. We'll create later. Okay. Sorry. Okay, so let's create the table again. Should I put it on? Should I put the script on? time, so you don't have to type it in the shell, which I think is a lot more annoying. Am I missing anything? No? Okay, so here's where you want to be careful of. After you specify everything, before you hit the semicolon in the enter, you put engine, and you want to use this one. And that's it. Okay. Then you hit it. Okay. And now I'm just going to quickly insert the values again. So we have it in here. Is this going too fast or it's fine? So now we will create the enroll table. If we finish the student table, then we just do the enroll table. If you have not, if you're not with us, all the commands are on the slide. You can just type the exact same thing with modification that I just did. Okay, we type in the enroll table now, and then we'll demonstrate how the constraints will affect some transaction history. So here is the new thing that we want to do foreign key. Okay, remember the foreign key, studid in enrolled is the foreign key, right? And we want to references to the students. Okay, is that? And that's it, no mistakes. Okay. Then, before we finish, also don't forget to put the engine equals to. And then semicolon, and we hit it. Okay. So if you want to add in the values for enrolled, I also have that on the script right here. So it's just this one. We have 4 couples for enrolled. Okay, if you copy that, just directly paste it. And that will give you the contents for it. Okay. So again, if you want to see how the enroll table looks like right now, select all from enroll. Okay. When you hit enter, then you will see that. Okay, all good? Okay, so let's try to do something that will give us error. So, as we see, if we go back to check what are in the students table, you can see we already have these students, right? And on the left-hand side, yeah, it's kind of messy, but on the left-hand side, those 5 digits ones are the SID. As we said, because SID is the primary key. Is it allowed that we insert rows that have same SID? No, right? So we can try it out and see how it will happen. So you can say insert into the students table. Right? That's how we insert values. And then you do values, and you can specify the value you want to do. So let's just try whatever. Say we want to repeat the same ID as this guy. Okay, so you can put 5, 6, 3, 6, 8, 8, and just some random name. Mike. Okay, maybe my major's in E. 17 years old. GPA 3.4. Okay? The whole point here, you can enter whatever as long as it follows the schema. So if you have an SID that repeats the ones that already exist in there, then it will tell you duplicate entry. Okay, so that's an error right there. Another thing that will give us error will be, let's see. So for the primary key, can it be null? Okay. If you want to recall whether the primary can be null, you can describe the student's table again. And as you can see, here it says SID, null, no. Right? Because it's the primary key, so it will not allow you to have the SID and to the student's table. So there are a couple of scenarios you want to think about what will happen when you do. So what should be done is an enrolled tuple with a non-existent student ID is inserted. What do you think? So for, let's say we don't do anything with the student table, and we already have all the students listed in the student table, and now you want to add some enrolled relationship into the enrolled table, and then you enter the value with a student ID that actually does not exist in the student table. What would you do? Error. Should you reject such insertion? Yeah, I think that makes more sense, right? So when you want to enter that enrolled relationship with the students actually not exist, you should not allow that to happen. Okay? That's the first thing you want to think of. But in different designs, maybe when such values to be inserted, you can say, okay, I'll insert an enroll relationship, and for the students, I'll enter just the ID with all the other values being null. Okay? If that will apply in your scenario. Another thing that might happen is what should be done if the student's tuple is deleted and the student also exists in the enrolled table. So we have these couple of options that you can think about. The first one is to delete all enrolled rows that refer to the deleted student row, which I think makes the most sense, right? That makes sense. Another thing is disallow the deletion of the student's row if an enrolled row refers to it. Okay, so the second one is just don't even allow such transactions to happen. The third option is set the student ID column to the SID of some default students. So you still delete from the student enrolled such row, but then for enrolled row, maybe you can just put the student ID as a default value like 9999 or whatever. Okay. However, for the last option, I think that's not an option. The last thing that I note right here is if you choose the option of setting the student ID as null, it will actually contradict with the fact that it's a primary key, right? So it should not be. So you can just think about how you would do this whenever you design your model. Last thing. What should we do if the primary key value of a student's row is updated? Do you think that will make sense? Like student's ID, then update it? Yeah.
Well, I I guess if you were actually allowed to do that, you'd have to update all the student IDs that reference it. But then I don't think that that'd really be, I guess it depends when you create it, if you allow that or not.
Yeah, exactly. So the whole thing of the model design is when you change one table, you don't want to really change all of them that relate to it, otherwise then there's no point of separating them into different tables, right? So as Austin said, it makes more sense if you don't allow such change to happen. But if you allow so, then all of the tables that relate to the student table that mention the primary key should also get updated. Okay? So most of the time, it just makes more sense if you don't even allow the primary key to get updated. Okay? Like, I won't imagine your student IDs, like, maybe after 4 years, both years suddenly change. They're like, now you're a senior, your student ID is different. And everyone gets changed. Just awkward, right? Like, it took me 2 years to memorize my student ID. Now I'm not remembering it again. Okay, so for referential integrity, so this is how we would do it. We won't type it in today, because I think it'll make me, we drop the table again. So this is how you would create the enroll table. Okay, so up until here's all the thing, right? And this is the fact that you have to say which is the primary key reference. But yeah, here we add 2 more things. So that we call the actions that you want to use to take care of different kind of scenarios. Okay. So for here, the whole thing, all these added to it belongs to the foreign key. Okay. So the whole thing we call it the foreign key declaration. So if you say delete, then cascade. This cascade means rows referred to it are to be deleted as well. Okay, so that was one of the scenarios we talked about. The other one is on update. Okay, so that's when you update something, like for your insert or update a value. No action means you just reject it. Okay, so you can swap these two. Like we did earlier, if you on update and you do cascade, so then we will cascade all of the changes, say you primary. Okay, so if you do cascade, that would do that. Okay. So we have some other options that you can use that we just mentioned earlier. So for delete or update, you have these 4 options to choose. So no action, as we said earlier, is reject. And actually, if you don't specify it, I think by default there will just be no action. Okay. But if you do cascade, then that means for any deletions or updates, all tuples that refer to the deleted, updated tuple will also change. Okay. Then you can either set to null or set to default. These are the 4 actions you can do. So I think we'll just get to here today. But before you go, reminder, okay. Yeah, homework due this Friday. Okay, so you will turn it in class. Unless any special excuse, no late submission is allowed. Okay. Then bring your laptop again this Friday. I think that will be our last lab. Another thing is don't forget about the project. And don't forget your report has to be at least